This is a discussion of satisfaction or dissatisfaction with air quality and its importance on how we operate buildings and its relevance to whether or not we're maintaining a healthy indoor environment. From this plot, from a survey from the Center for the Built Environment at the University of California at Berkeley, it's quite clear that among over 200 buildings with over 30,000 building occupants surveyed, there's a lot of dissatisfaction. Most buildings, say more than 80% of buildings, have 20% of its occupants who are dissatisfied with comfort, dissatisfied with air quality. And on average, among this large number of people, 32% are dissatisfied with air quality. That's a large number. And if you're a business and you're trying to attract customers, you want as few things that are going to persuade them to go to your competitors. And air quality is for sure something which, with almost 10% of our populace afflicted by respiratory sensitivities, asthma, allergies, air quality is extremely important. Now, I just wanted to credit Professor Ole Fenger, a pioneer, the late Professor Ole Fenger from the Danish Technical University, someone who decades ago saw the importance of quantifying this field of air quality, satisfaction, and dissatisfaction. And he developed two special units, the OLF and the decipol. And the OLF is basically the pollution that one recently washed, clean clothed person operating at sedentary conditions, basically office level work, the amount of pollution they put off. And a decipol is amount of airflow defined as 10 liters per second, but that's about 20 cubic feet per minute, which is typical for building ventilation flow rates per person with today's building standards. And even though there were not the sensors and the instruments that could detect what this meant as far as air quality, by Professor Fenger surveying people and finding out their satisfaction and their dissatisfaction, he could map out this level of air quality. And basically, one OLF with 1 decibel of airflow would result in about 20% of the populace being dissatisfied. Now, this slide shows a couple of figures from a paper by Dr. Andrew Persily, someone who's been in the air quality and building energy business as long as anyone I know, since the 1970s when I started working in this. And Dr. Persily shows in this review paper uh, Professor Fenger's original plot of dissatisfaction relative to airflow. And as you get to levels that are below 20 cubic feet per minute, dissatisfaction starts increasing rapidly. And as you get below 10 cubic feet per second, you start having sick building syndrome. It's not only dissatisfaction, people are getting sick. People are definitely not productive and do not want to be in that space. The figure on the right shows data collected by Dr. Persily in around 140 buildings. And the ratio um, on the left shows the measured airflow relative to the design airflow. And you can see that most of these buildings are below 1, meaning that the ventilation airflow rate actually measured is less than that in the building. And in fact, it's quite a bit less. And where are we telling you that we'd recommend you get your airflow? Well, at about 2. That is about twice what is standard ventilation airflow today. And you can see very few buildings, about 3% of this group of buildings meet that standard that we recommend, and it's for your health and your air quality satisfaction. And we can translate Dr. Fenger's data over to carbon dioxide concentration. which is your easiest and least expensive way to monitor air quality as well as to manage it, that you can control air quality with a simple CO2 sensor. And at standard building conditions, about 20 cubic feet per minute per person, 20, 25% of the populace will be dissatisfied. And then, as the previous slide showed, few buildings actually operate at what they're designed at. Who knows whether it's poor maintenance, whether the installation did not match the actual design, but for some reason, a lot of buildings don't even make their design condition of airflow. But if you double that so that you have about 800 parts per million of carbon dioxide rather than today's typical 1200, you'll find that you'll cut air quality dissatisfaction about in half. You'll drop down to about 10 to 12% dissatisfaction. That's a large group of potential customers that you may have encouraged to come to your business compared to your competitors who might not be operating at that. And then you get to enjoy all these other benefits: fewer sick days by more fresh air, better cognition, better productivity out of your employees. Lots of good things happen with fresh air, and it doesn't cost much. So we need to redesign our spaces, not just control them better, but from top to bottom in order to get air quality dissatisfaction down. And among the things that we need to look at, try bringing air in from that side of the wall into your building. Why take air through a large set of ducts from one end of the building to the other, picking up who knows what in between, as well as all the energy expended in fans to blow air from that corner of the building to this one? Get the air where it's closest to your space and bring it in and exhaust it right there. You'll save capital costs, capital dollars in large expensive duct uh, costs, and you'll just be getting fresher air better when needed in those spaces. Um, you should also look at controlling air quality automatically and doing it online so that who's ever managing that space can easily see that things are functioning okay, that settings are okay, and that's going to save you money too, as well as help ensure that you're staying healthy and others around you are staying healthy. And putting in low and no emission furnishings, also known as Scandinavian design. Lots of hard surfaces, uh, minimal, if any, carpeting, draperies. One of Professor Fenger's early works was to do a blind study where a number of office workers, stenographers, were shown to have significantly lower productivity, typing skills, when unknown to them, some old carpets and drapes were put on the other side of a barrier so that they were unseen, but the impacts of the old carpet and drapery on productivity was profound. Couldn't smell it, didn't know it was there, but the impacts on human productivity definitely were there. And and then let's think about those who have respiratory sensitivities. There's a lot of us. There's about 10%, about one in every four homes. You're going to find someone in that home that has asthma, has an allergy, and every time they walk through a doorway, they're wondering, is this going to be a safe place for me to take a breath? Or am I going to have an emergency? Let's think about that and let's plan and let's ask people so we have a better understanding how to design a space. And this isn't future technology. Here's a demonstration space. It's what I think is maybe the perfect office. Fresh air just on the other side of the wall, a very energy efficient office with a very high performance heat pump for heating and cooling. The person in the office can set whatever level of comfort they want, whatever level of air freshness they want. And they were very, very happy. And the Other folks along the hallway were very, very jealous. So let's improve our buildings. Let's reduce air quality dissatisfaction. It's going to save you money. It's going to increase productivity.